Okay, this is lesson 6.4, percents of increase and decrease. So today we're going to find the percents of change in quantities. The key idea for a percentage of change is the amount of change divided by the original amount. Another way to think about this is the maximum number minus your minimum number over the original amount. And then, of course, we would say if it was an increase or a decrease. So looking at example number 1, we have finding a percent of increase. You spent 2 hours online on Saturday and 4.5 hours online Sunday. What is the percent of change in the time spent online from Saturday to Sunday? So the first thing we can notice is that instead of the 2 hours on Saturday, we spent 4.5 hours on Sunday. So we know that our answer is going to be a percent of increase because our hours increased. So then, looking at our numbers, we're going to take our maximum number, our 4.5, subtracting our 2, that's our maximum minus our minimum, divided by the original or starting amount, which was the 2 hours. So we plug that into our formula. Okay, so we're going to have 2 in the denominator. 4.5 minus 2 is 2.5. And then our last step when we have a fraction is to divide, and we end up with 1.25. And that is our decimal. We want our percentage for that. Remember, the 1 in front of the decimal here means 100%, plus the 25 after it for 25%. Or you can take this number. Remember, you can always just multiply by 100 to get your percent. And our answer is 125% increase. Okay, I want you to pause this video and try the next 2 questions, and then turn it back on to check your work. Okay, let's see how we did on number 1 here. Our maximum minus our minimum is 25 minus 10 over our original 10, which then gives us 15 over 10, which works out to be 1.5. Our numbers went up, so we have 150% increase. Okay, looking at number 2, we have 57 to 65 people. 65 minus 57 over our original 57. We definitely have an increase here. This works out to be 8 divided by 57, which is 0.14 or 0.14, which means 14% increase. Okay, in our next section, we are doing finding a percent of decrease. The bar graph shows a softball player's home run totals. Okay, it looks like here we have the season 2014, 15, 2016, 2017, and along our x-axis, the number of home runs for each of those years. It says, what is the percent of change from 2016 to 17? So we're focusing on 16 to 17 here. Maximum minus minimum is 28 minus 20 over our starting amount, which would be the 2016 value of 28. Okay, when we subtract our numerator, we get 8 divided by 28, and that works out to be 0.286, which when we translate that, we can multiply by 100. That is 28.6% decrease. Okay, pause this video and try the try it question, and then turn it back on to check your work. Okay, in example number 2, what was the percent of change from 2014 to 2015? So we have 18 minus 10 over the original 18. 18 minus 10 is 8. 8 divided by 18, numerator divided by denominator, we get 0.444. So that's going to be 44.4% decrease. Okay, we're going to turn it over to the next side. Okay, sometimes we are calculating not for a percent of increase or decrease, but percent error. Percent error usually means how much you're off by in an estimation. So percent error, this right here is always a positive number because it's how much you're off by. Okay, modeling real life. You fill bags with about 16 ounces of homemade dog treats. The acceptable percent error when filling a bag is 5%. Tell whether each bag is acceptable. So looking at bag A, we have 16 ounces versus 15 ounces. So that's our maximum minus minimum, or our amount of error, out of the actual amount, which should be the 16. Okay, so it's how much you're off by, and then your denominator is not your starting number, it's your actual amount. Okay, when we subtract, we get 1 over 16. So when we divide that out, we get 0.0625. So that's going to be 6.25% of error. Okay, that is more than the allowable 5%. So this is not acceptable. Okay, that's not acceptable. Now we have to try and check bag B. That is 16.5 minus 16 over the 16. So here we have 0.5 divided by 16, which when we divide, we get 0.0325. So that's 3.25%. That is well within the 5% error, so this is acceptable. Okay, pause this video and try the try it question. Okay, number 4. In one round of a game, you are asked how many bones are in a human body. If the percent error of your answer is at most 5%, you earn 2 points. If the percent error is at most 10%, but greater than 5%, you earn 1 point. You guess 195 bones. The correct answer is 206 bones. How many points do you earn? Okay, so we're going to do our maximum minus our minimum over the actual amount and see what that percent error is. So 206 minus the 95 over the 206, which is your actual. So we underestimated here. When we subtract, 206 minus 195 is 11. So 11 divided by 206, which is 0.053, which is 5.3%. So that is over our 5% for earning 2 points. So between 5 and 10, for this question, you would earn 1 point. Okay.